Hi everyone. Today we're going to be taking a look at diffusion and we're going to be taking some notes with it. And I want you to consider some things you already know when we're going through these notes because you've actually experienced and witnessed diffusion. Also keep in mind that diffusion has something to do with your egg project. You see, diffusion has to do with the transport of things in and out of the cell. So let's look at cell transport. After you finish this page, hit pause and take some notes that you need for your egg project and for getting ready for the next test. But what does a cell need? Well, most of you would probably say oxygen, it needs food, it needs water. Well, it definitely needs water all the time. It needs oxygen, absolutely, and it needs food. But there are other gases that it might need, but we'll go into that later in the year. So first of all, let's just review that the cell membrane controls the movement of stuff in and out of the cell. That might be chemicals, it might be nutrients, etc., etc. And it's going to let some things in and let things out. It's also going to get rid of waste by letting it out. Okay, so what is a cell membrane like? I would compare it to a mesh bag, a screen. I've talked about in class, it's like a screen on a screened-in porch. And it's going to let small particles in, but it limits the movement of other things. And that's where things get interesting. So cell membranes are selectively permeable or semi-permeable. Those terms mean the exact same thing. And what's great is that they let oxygen and water go in without any effort. It just goes right through, just like water or air would go through a screen. So diffusion, specifically, is defined as atoms or molecules that move from a crowded area to a less crowded area, or they might use the terms a high concentration to low concentration. So if you had lots of different particles, you can see right here that I'm drawing, perhaps they come from a perfume bottle or a very fragrant deodorant or cologne. I know that's happened sometimes in class where people have something that really smells great, but too much is just too much. But as it goes out, they actually will bounce around and they'll move from a crowded area into a less crowded area. Those particles actually start moving and they spread out. And they just keep spreading out. Now let's take a moment and just remember that diffusion is something called passive transport. And that means that you don't have to use any energy at all for this to happen, which is really cool because we need to be able to get oxygen and water into our cells without having to use up energy. If you were having to use energy all the time just trying to get oxygen in, you wouldn't even have any energy left to grow and to digest and do all the things that need to be done in your body. So it's critical that the universe is based on this, that diffusion happens without any energy being used up. All right, so special name of diffusion of water. All right, so you're like, great. Another thing to remember. Just remember, diffusion is when the particles move from crowded area to a less crowded area. Remember, we have a special name for the diffusion of water, and it is diffusion. But when we say it's osmosis, that means we're moving water from more crowded to less crowded, or a high concentration to a low concentration. So, can you think of an example of osmosis? What did you have for breakfast? Perhaps you had some cereal, and that cereal had milk on it. And the milk contains water, and the water went through the cereal until it got kind of mushy. Or perhaps you had some spaghetti. How in the world did that dry spaghetti get nice and soft and squiggly for you to eat? The water diffused through it. So let's get technical. When you look up the definition of diffusion, it says the process by which the constant motion of molecules causes movement of an area from an area of high concentration to an area of low concentration, like burned toast or perfume spray. Think about it. Have you ever smelled burned toast from really far away? You didn't even know someone was cooking burned toast, but suddenly you knew it. You knew they were cooking toast. You knew they burned it. Well, diffusion actually explains how you were able to smell it from so far away. The particles inside the toaster oven started bouncing around. It started burning. And because it was moving around, it actually spread out and moved from more crowded to less crowded. So it comes back to passive transport. As things move in and out of the cell, I've already mentioned water and oxygen do not need any energy. It just passively goes through. And it's because the particles move like particles or the balls of in a pool game, like when you're playing pool on a pool table. The particles move in a straight line. They bounce and ricochet off of something, and they continue to move in that fashion. But when they bump into each other, they bounce off into new directions. So that's what happened with the burned toast. The burned toast, all those particles are moving around. They bounced out through the door and started spreading out throughout your house. Now, take a moment and be sure that you have good notes taken on diffusion and passive transport, because there's one more thing we need to add. Come back when you're ready. Okay, there's something called active transport. And active transport does require energy. There are times out in nature where something has to be transported over the cell membrane and it requires energy. So if you go back and think about it, diffusion went from more crowded to less crowded, because it's easy to go from a crowded area to step into perhaps an empty hallway or something. It's easy to think about how those particles have moved to a less crowded area. But with active transport, they move from a less crowded area into a more crowded area. Then it has to hold itself there. For example, root cells. Well, they're particles that they need in the soil, and it pulls it into a root that's already crowded. If the root did not actively transport it, those particles are really crowded here. They would just automatically go from more crowded to less crowded and go back out. It's got to hold it in there. So not only does it have to pull it in, it has to hold it in. So that is actually an example of active transport. So it's different than diffusion or osmosis. So diffusion and osmosis are passive, and active transport is transport over the cell membrane, but it actually requires energy. All right, so let's sum it up. Let's see if you get this. If you have problems with this, you need to come over to me in class or email me and let me know so I can help you further. All right, so let's pick the type of transport. Active or passive transport. Riding a bike up a hill. Well, obviously, this is just a figurative example, but does it require energy? Yes, it does. So, if it's requiring energy, you would say it is active transport. How about coasting, riding a bike downhill? Just coasting, just sitting on it and going downhill. That's right, it's passive transport. But why? Think about it. That's right, it does not require any energy. Okay, smelling toast from across the room. Did it require any energy, any effort, or did the particles just move from more crowded to less crowded? So it should have been passive transport. How about smelling Mr. Duckworth from across the room? Particles were more crowded on his clothing. Of the fresh, wonderful smell of clean clothing and nice detergent. And then it spread out from more crowded to less crowded, or a high concentration to low concentration. So it's passive. How about a plant getting food out of the dirt? That's straight from our notes. Turn back and look. Think about it. Plant is having to pull the nutrients into the roots, into a crowded area, so therefore it's active transport. It requires energy. Well, great job. You did a fantastic job today on the notes on diffusion. So when you think about particles going from one area of a house to another, they're probably moving and diffusing through the space. So you know now and understand that those particles that started off really close together started bouncing off of each other and ricocheting and started to then spread out and move. And now you might better understand why something might be crossing your egg project's egg cell membrane. Think about it.